goal of our problem then is to prove that NMC is a straight line. We're given A, we're given B as our vectors, and we're told some facts about our points. We've got that AB is equal to BC. So this line here is equal to this line here. So straight away, we can write down that this little vector is going to be A from B to C. Beautiful. And we've got that PM is equal to MB. So PM is equal to MB. So that tells us these two little sections are identical. So effectively M is the midpoint there. So goal of our problem then is to prove that NMC is a straight line. So N to M and M to C. Looks like a straight line in the diagram. Hopefully we can prove that too. The way to think about this is to kind of split it up into two sections. We have N to M and M to C. So N to M and M to C. They both contain M. Quite clearly, N to M does contain M, and M to C does also contain M. So if we can prove that NM is parallel to MC, that's the same as proving that it's a straight line. So this is effectively equivalent to what we have above. So that's going to be our target. We're going to find NM, we're going to find MC, and we're going to show that they are parallel. So that's just what these two little lines mean. Spot on then. So first things first, we'll find NM. So let's have a look. N to M. That is going from here to here. So what we can see, we can kind of take this path that way, or we can go right along here to here and back here again. Take the short path, probably a little bit easier. So N to M, and all of these should have arrows on them really as well, is going to be equal then to N to P along here, which we can see is just denoted by B. So that's just going to be B, plus then P to M. We now need to figure out what is P to M. Well, P to M, we know that P to M is also M to B. So P to M is actually half of P to B. So one step closer. And now we can figure out what P to B is. Well, we can get there using lines that are fully covered by our A and B's. So what we can see, we went backwards through 3 B's and forward through 1A. So P to B is equal to, well, forwards through 1A and backwards through 3 B's. Spot on. So now we can expand this bracket and get NM in terms of just our A and our B. So in terms of A, well, we have half. And in terms of B, there's 1 here, and then we take away 3 halves. So 1 take 3 halves gives us minus 1 half of B. We'll factorise the half out. What we get is it is a half A minus B. Spot on. Second section then. We now want to find MC. So this little part, just going from M to C. So we can see how we're going to get there. We're going to go to B, and then we're going to go from B to C. So MC is going to be M to B plus, and B to C, we can see straight away is just A that we've put down there. Beautiful. So what is M to B? Well, we were told that M to B is P to M. And P to M, we've worked out up here, is actually all of this section down here. So it's the half A minus 3B. So this thing then, M to B, is a half of A minus 3B. And we still have the plus A from before. So altogether, if we expand this out, how many A's do we have? Well, a half there, plus 1 more, makes 3 over 2 A's. How many B's? Well, we've got the minus 3 times by a half. That gives us minus 3 halves. So now then we can factorise this out. 3 over 2, all of minus, well, A minus B. Beautiful. So now then, when we look at MC and we look at NM, what we have is that they're both a multiple of A minus B. So, therefore, what we have is that N to M is equal to 3 times of M to C. So, they definitely are parallel. And because they're parallel, what we have is that they are all in one straight line with each other because they also share a point. So that tells us that NMC is a straight line. Beautiful.